me on the other system to say, how do I get a copy of my, to pre-answer one question on how do you get a copy of Michael's report? He sent me a copy here. If Michael and Peter are agreeable, and Peter's agreeable, I will email that out to the delegate list in the next day or two, if that's okay, Michael.
Absolutely fine. Yep.
Okay. Well, thank you all. We've even got questions before we start. Okay. Thanks ever so much. Okay. Good evening, everyone, and we are nearly at the point when we should be kicking off. Tonight is something slightly different for us all. We already have the largest audience we have ever had for our talks. If everybody turns up tonight, we will have 222 people here. I shouldn't really say this, please don't all turn up. I don't know if I can cope with it. Okay. It's a joint meeting tonight between the Newcomen Society and the Stevenson Locomotive Society. I've asked the chairman of Stevenson, Brian Dotson, if he would like to join us and say words. Brian, do you want to say a few words and I'll deal with all the housekeeping stuff at the before I kick off?
Yes, that's fine, John. It's hello to everyone, and I am absolutely delighted that so many people have signed up for this meeting. You know, over 200. I think it's beyond everyone's wildest dreams. It's absolutely great. And I'm very pleased too that the Newcomen Society and the Stevenson Locomotive Society have teamed up to provide this lecture. I should point out that the next joint meeting is expected to be in November, given by Michael Bailey, and it'll be about Killingworth Billy. That's going to be in Newcastle, but arrangements so that everyone who wants to hear it or see it will be made, and the information will be coming to you shortly. I'm quite certain that for those people who know about the work of Dr. Michael Bailey and Peter Davidson, that I really don't need to say anything more. They're just superb speakers, and we're in for a real treat tonight. So I'm looking forward to this presentation very much indeed. Thank you, John.
Thanks, Brian. Brian, could you mute yourself and turn your video off, please? And then
yes.
Okay. Just a very quick bit of housekeeping. If you want to ask questions, please use chat. I'll be monitoring this all the way through, so please put your questions on whenever you want. I will be picking the questions up at the end. At the end, I will also be unmuting Peter Davidson. Peter did the research with Michael, and Peter will be there to do it. One or two other people who've also been involved with the sort, we may unmute them if there are questions which are more things there. Michael, the floor is yours. Thank you very much. I will now turn myself off and leave it to you.
Very good. Thanks very much indeed, John. Well, good evening, everyone. And thank you for tuning in to this talk about the Invicta project. Peter Davidson and I undertook the project in the first half of last year. In fact, we actually managed to finish the field work for the project before the first lockdown in March of last year. So the timing was very fortunate. Now, to undertake a project of this nature, it's necessary to have an understanding of the state of our knowledge of the subject, in this case Invicta, before we start. So what I propose to do is to just quickly summarize the current state of knowledge about the locomotive, so that we can all start, as it were, from a common base, and then it'll make much more sense when I come to explaining all that we found out during the project. Invicta was the fifth locomotive to be built after the rocket. It was built in the early 1830s, so some 4 or 5 months after rocket. So there will be inevitably similarities that we can identify between the two locomotives. It was built to the order of the Canterbury and Whitstable Railway. Now, the Canterbury and Whitstable Railway was just a 6-mile line from the cathedral city to the little fishing village of Whitstable. And as you can see from the gradient profile, it had a massive great hill in between, which had to be surmounted. When George Stephenson had the responsibility for the line, he recommended to the directors that they employ 3 stationary winding engines for the steep inclines. Starting here from Canterbury and rising up is the first of the inclines, the oh dear, forgot the name now. Yeah, Tyler Hill incline. Then you have just over a mile of level ground, and then a decline from the top of the hill all the way down to this point here, which has the delightful name of Bog's Hole. That incline was known as the closed wood incline. Then there was another 2,000-yard stretch of level line before the final decline down to the sea level, with gradients of 1 in 50, 1 in 57, and it was all 3 were engines, stationary winding engines, had been ordered for those 3 inclines. Now, after the first 2 had been built by Robert Stephenson and Company in Newcastle, Rocket won the Rainhill trials, and the whole engineering world at that time was full of excitement with regard to its success. And the directors of the Canterbury Whitstable Railway asked for to be consideration for the lower incline, this in Whitstable, the Church Street incline. Could it be worked by a locomotive instead of a winding engine? And I'm pretty sure that the reason why they asked is because the Loco would cost just over £600, whereas the winding engines would cost more like £1,500. So there was every incentive for the railway to try and do it much more cheaply than hitherto. So this is a very familiar view illustrating the opening day of the Canterbury and Whitstable Railway. It provides a superb perspective of the little fishing village of Whitstable there. And right here is the sea wall from which the Invicta, which had been shipped down from the Tyne, was discharged and assembled. The painting, good as it is, it's got an awful lot of errors, not least of which is showing Invicta here going the wrong way. You would never go uphill with your firebox leading. So the next slide I've got is the first of the 4 individuals who have an extraordinary influence over the Invicta's career. This is Edward Fletcher, obviously seen in much later on in his life, who as a young man was an apprentice at Robert Stephenson and Company. And he had helped to erect Invicta. And he completed his apprenticeship and was asked to come down from the Tyne with the Invicta, reassemble it on the seafront, and make sure that it was in good working order, ready for the opening day. In fact, he spent the first 3 months actually driving Invicta and training the staff down in Kent. Now, Edward Fletcher, who went on to a very successful career in locomotive management, he always had that deep interest and association with Invicta, which we shall see as we progress through the evening. This splendid model, absolutely splendid model, is a 1/8 scale model of Invicta as it was built. It was owned by Fletcher later on in the century. We would love to know whether or not he actually made the model, but it's impossible. We just haven't got the evidence to confirm that one way or the other. But it is so accurate that it has been extremely useful. Now, we've known about this model, but it is now in private ownership. Most recently, though, anyone who had the opportunity of going to the National Railway Museum and seeing the steel, brass and fire exhibition, which finished well, pretty well a year ago, but for the COVID problem, you would have had the opportunity of seeing it. But I imagine that right now it's been returned to the owner. Now going to introduce the second of the people who had such an influence over Invicta. This is Thomas Cadbury, again seen in later years. He also had been an apprentice at Robert Stephenson and Company, and he was made the resident engineer, as it were, on loan from the Stephenson Company, resident engineer on the Canterbury and Whitstable Railway. So he it was who set up the winding engines, made sure they worked properly, as well as looking after Invicta. Now, it was during these early months that we know that Invicta's performance was not as good as it was expected. In fact, the lack of load that it could haul up the Church Street incline meant that the railway was suffering quite badly, and so it decided that it would accept George Stephenson's original recommendation and install a third winding engine on the Church Street incline, and therefore leave Invicta to operate on that level stretch, that 2,000-yard level stretch from the top of the Church Street incline to Boggs Hole. And it soldiered on then until 1836 in that duty. And then in 1836, this extraordinary rebuilding took place under Cadbury's leadership. He removed the tubes, multiple tubes, he removed the firebox, and he lengthened the boiler barrel, and he put in a 20-inch diameter single flue through the boiler. This has been known about, you just have to look at it to understand. But the big question is, why did he find it necessary to do that? So this is one of those major problems that we sought to try and find the answer to. The next view we have is Ashford. Now, the locomotive came out of service in 1839, was offered for sale, nobody bought it, so it was popped away into a shed and pretty well forgotten about. The railway then was first of all leased and subsequently acquired by the South Eastern Railway, which operated between London and the various towns in Kent. They, having acquired the Canterbury and Whitstable Railway, they had they found themselves with Invicta on their hands, and they took it to Ashford. Again, we don't know why. Ashford is the site of the locomotive works of the South Eastern Railway, which was established in, well, they started building it in 1847 and finished it in 1850. Was it something to do with the workshops? Why did they transfer it? What did they do with it? There just is no record surviving of what went on in Ashford Works that would explain to us what Invicta was doing there. In fact, we don't know, we haven't hitherto known what happened to Invicta in the second half of the 19th century. Okay, we do know that it was displayed in 1875 in the Jubilee celebrations for the Stockton and Darlington Railway in Darlington, and a little bit later, 6 years later, it was displayed in Newcastle for the George Stephenson centenary. More about that a little bit later. Next thing we know is that at the beginning of the 20th century, it was put on a plinth in the gardens in Canterbury, the Dane John Gardens, and it looked very odd. If you just remind yourself of what the model was showing us, the components on the restored Invicta look very different indeed. So there's a lot to be explained. So, of course, it stayed there for many, many years until 1977, 78, and inevitably it deteriorated. So it was taken on by the Transport Trust, who said, look, we can't allow Invicta to carry on deteriorating out in the open like this. And having acquired it, they managed to obtain grant funding to enable them to take the Loco up to the National Railway Museum in York to recondition it. Now, this would have been an excellent starting point for the study to have understood what work was carried out on this reconditioning. But surprise, surprise, there was no project report was prepared. And I found this amazing, but an awful lot of work was carried out, but Peter and I had to investigate the locomotive in some depth ourselves to find out exactly what work they did carry on. After the restoration, then the locomotive was taken back to Canterbury and put on display, incidentally with cladding, as you can see there, put on display in the Canterbury Heritage Museum, for quite many years, from 1980 right up until just 18 months ago, when it was moved to Whitstable, to the Whitstable Community Museum, where it now resides. And it was the friends of the museum who asked if we would undertake this study to try and answer a lot of these questions. So there's a lot of queries that I've outlined there. We hoped that we would find out more about the design work undertaken by Robert Stephenson and company, as well as the history of the locomotive itself. The evidence, of course, firstly, is the locomotive itself. We undertook a detailed component by component investigation of the locomotive to try and understand what has actually happened during its life, what components have been put on at what time in its history, to try and understand better exactly what it is we're looking at now. The second source of evidence were two original arrangement drawings prepared by George Phipps, who was the Stephenson Company draftsman at that time, and they have survived, and they are in the search engine facility in the National Railway Museum, and they have proved extremely useful. The third evidence is, well, this painting, I pointed out that there's an awful lot wrong with it, but nevertheless, there's an awful lot right with it. So that's a useful piece of evidence. The fourth was Fletcher's model that I showed earlier. But the fifth source of evidence is the surviving archives. And it's this combination of the archival research and the archaeological which makes the project so enjoyable and absolutely fascinating. Right, let's start with the investigation itself. And we start with the boiler. Now, the boiler, as we know, this was the fifth engine after Rocket. Rocket was successful. It had 25 tubes of 3 inches diameter. The 4 locomotives built for the Liverpool and Manchester Railway after Rocket had tubes reduced in diameter to 2 inches, and they put a lot more in. And by so doing, they doubled the heating surface. With Invicta, big question, how many tubes did it have? Well, as luck would have it, a chap called Simon Goodrich, who was an engineer for the Navy Board, visited the Stephenson Company in March of 1830, by which time the locomotive was 80 or 90% complete. And he records in his diary, God bless him, that it had 154 copper tubes inside its boiler. Each tube was 1 5/8 of an inch in diameter. Now, this is extraordinary to jump in just a short few months from Rocket's 25 tubes to Invicta's 154 tubes. It must have been very crowded there. There's hardly any room left for the water. And it trebled the heating surface. Now, this is extraordinary news because it means that the development engineering that was going on, it was all done on an empirical basis. If it works, do it again, but do it bigger or have more examples of them, as in this case. So that, of course, this is evidence from the archives, because it's no longer there. But nevertheless, having learned that was extremely useful. We now come to 1836, when Thomas Cadbury undertook the rebuilding that I indicated earlier. Now, the problem with the Canterbury and Whitstable Railway is that it was grossly undercapitalized. They were always scraping the barrel for money. That third winding engine, which they had installed for the Church Street Incline, when it came to Robert Stephenson putting in its bill, it was ignored. The company couldn't pay it. And a dispute broke out between the two companies, and it got nasty. It lasted for 2 years or more, and there were threats of letters from solicitors and finally court action. So it really got very, very difficult indeed. So we'll put that one to one side. Now, Thomas Cadbury, he suddenly found himself with a major problem. Those tubes, after 6 years of use, were worn out. Worn out for two reasons. Firstly, the scouring of the inside by the coke particles passing through the tubes. Now, this was a problem which we know about from the reports on the Liverpool and Manchester Railway. And their tubes didn't last very long because of this scouring effect. But the water that they had on the Liverpool and Manchester was soft water. Here in Kent, it was hard water. And the problem with the tubes was the hard water was attaching itself to the tubes themselves. The water was just hopeless and in spite of Thomas Cadbury, I'm sure, having washouts as often as he could, nevertheless, the furring on the outside of the tubes was serious. Also, with the firebox, he would have had the same problem. So you can imagine Cadbury having to go to the directors and say, I can't keep Invicta working. It has to have a new set of tubes and a new firebox. And the company hasn't got any money. It hasn't even paid Robert Stevenson and Company. So what was it to do? And they appealed to Cadbury, you must keep Invicta going at all costs, otherwise the whole line will stop. So Cadbury fell back on his experience and the knowledge that he had gained during his time with Robert Stevenson and Company up in Newcastle. During his apprenticeship, the locomotives of that day looked like this. They had a 20-inch flue running through them during the 1820s. And this is what he remembered. And so what he did was he removed all 154 tubes. He removed the firebox. And then with the space available, he extended the boiler by one additional ring. You can see the additional ring here. By doing so, he also penny pinching way, he retained as much as he possibly could. The end plate here, you can see, has been recovered from the end of the boiler that it used to be there, and you can just see the outline of the two holes for the communicating pipes with the firebox, and so they're still there to be seen to this very day. He then obviously put in the 20-inch flue through, and amazingly, it all worked, but there was a major problem, because putting on an additional ring is not as easy as it sounds. You can see that the fourth ring has been riveted to the outside of the third ring. The angle iron and the end plate had been recovered from that position originally, and therefore for this plate to be fitted within the angle iron, it would have to be conical in shape, because for the obvious reasons there, and you can just about see the cone forming. Here, the butt and strap method of riveting the plates together has gone a bit awry. Now, I tried to find out which contractor had undertaken this, but there was absolutely no record at all. And I've come to the conclusion that it was actually undertaken by the maintenance workshop in Canterbury of the Canterbury Whitstable Railway, anything to keep the cost as low as possible. But they're not experienced boilersmiths. And therefore, I think any experienced boilersmith would be horrified at the sort of hash job that this is. But nevertheless, it worked, even though it's been just squeezed in as best as they could. And it worked well. And Cadbury, actually, I think, is a bit of a hero, because it did work. He used his experience well. Now, afterwards, we're fortunate enough to have a press report of the locomotive working after the rebuilding had taken place. And this is a press report in September of 1836. And I'll read it verbatim. "You're meeting with a lively companion, the locomotive engine, which, being attached to the train at the top of the Church Street incline, presently moves along at an incredible pace. Now you are all life. The engine proceeds with a loud roaring noise as the steam is admitted into its numerous chambers, while in its progress balls of red-hot coke escape from the furnace, giving out a most intense light. Arrived at Bog's Hole, your fiery conductor leaves you." Now, that's a rather splendid quote from a journalist, which tells us much about Invicta after its rebuilding. Just a couple more views. This is a view looking inside the boiler through the inspection hatch cover. There you can see that end plate that we saw earlier from the outside. It's been plated over, and here is the single flue that was inserted. You can see the button strap arrangement is just out of true. It's not. It's just been squeezed in, and over this side there is no button strap. It's actually overlapped. So it's a very odd piece of boiler making. In this slide, you were looking down again through the inspection hatch into the boiler, and there you can see the flue from the outside, and here is a view looking through the flue from the fire grate end. And you can see here, it's made of 3 plates. You can see where they overlap has survived, but in various places, it's been completely and utterly rusted away. The extent of the degradation of the metal during all of its time on display outside in Canterbury has just eaten away so much of the metal of the flue and the bottom of the boiler, as I'll come on to. And you're left with this sort of skeletal effect of where the plates have overlapped. Right, now, so much for the boiler. Let's move on now to the frame. Now, the frame of Invicta is very much like that of Rocket. In fact, it's pretty well identical. It's you can see the frame there with a step down, and that was to accommodate the firebox in the first instance. The boiler itself was supported by 3 pairs of brackets on the top of the main frame, and the frame itself was purely for the vertical loading, for the weight of the boiler to be contained, and also the sprung loading on the underside. It wasn't so much to do with the horizontal loading from the train itself, because that was taken through the firebox and the boiler working in tandem with the frame. As soon as Cadbury removed the firebox and extended the boiler by that additional ring, then straight away he's putting on a sort of stronger bending moment, which required the insertion of a 4th pair of boiler brackets just there. In addition, of course, now the frame itself is taking the full train load, and it needed strengthening. So what he did was to insert just here a beam across the 2 steps, in the middle of which he has inserted a drawbar, taking it back to the rear of the frame itself. From the steps forward, to make the frame much more rigid for the purposes of train haulage, he's inserted 2 stay bars, one on either side, from the step all the way through the horn legs, all the way through here, and then up to the leading part of the frame. That's stiffened up the frame significantly to make it possible for Invicta to haul normal train loads. Now, the next slide I've got shows this as it is in real life. Here is the rear of the frame, wrought iron, just 4-inch by 1-inch wrought iron bar. The end of the boiler now is stayed to that at the frame end. And here, just looking a little bit further, you can see here is the step in the frame. And here's the other one on the other side. Here is the bar right across there, which he has inserted. And to keep it on as cheaply as possible, he has used a length of fish-bellied rail. Now, fish-bellied rail in 1836, that would have been provided originally for the track work of the railway. So it was almost certainly rolled at the Bedlington Ironworks. Here is the drawbar, which I pointed out on the sketch. Just a little bit ahead of that, again, looking on the underside, looking up, here is the step. That's the main frame there. Then it's the step and the back part of the frame here. Here is the stay, which was screwed into the step itself, and it runs through the horn legs all the way through to the front of the frame, as I indicated on the previous slide. So, whilst we're here, we can also see the horns and the bearing, very similar to that which John Glitherow and I saw on Rocket. John, I think, is with us this evening. Hello, John. It's very useful to make comparisons between the evidence that we saw on Rocket itself and the way it had progressed here. In fact, the bearing is rather more robust than the bearing that we saw on Rocket. The next component is the cylinders. Now, the cylinders are bolted to a framework on the side of the locomotive in exactly the same way that was done for Rocket, whereas in Rocket's case, they were rearward facing. In Invicta, they are forward facing, but otherwise the function of the framework for the cylinders is identical. Peter and I took off the cylinder end cover, as you can see here, peering inside the cylinder, and you can just make out the steam passage exit at the upper part of the cylinder casting there. In this view, we have got a view looking down through the cylinder onto the piston. And the piston itself is, again, familiar because we've seen it before on Rocket, but also there is another example on display in the Smithsonian Institution in Washington, DC, the piston which had been formerly used on the Pride of Newcastle locomotive, which had been sent to America by the Stephenson Company even before Rocket. Right, now we come to the valve chest. Now that gets really interesting. The valve chest sitting on top of the cylinder. You can see here the top of the cylinder, but this is a separate casting from the cylinder casting. And between the two, there is a 1/2 inch thick seal, kind of gasket-like seal. So what on earth's going on here? This took a little time to sort out. So I'm going to go forward to a multi-presentation here. First of all, we're looking at George Phipps's original arrangement drawing, and we can see that he had produced the drawing for a valve, a long valve, which is as long as the cylinder, not a small valve chest, but a full-length version. Correspondingly, inside is a full-length valve, much longer than the valve that had been used on the previous locos, like Rocket. So what was going on here? Well, he obviously decided that it would be much cheaper for the foundry to cast a cylinder without the long steam passage running along the top of the cylinder. That's a very difficult piece of casting, and it took time, and there's always the possibility of failure. So he tried to overcome this. Now, there are two problems by having the long valve inside the long valve chest. The first one is that there is the port faces are correspondingly very long, and under the steam pressure of the steam coming into the steam chest, it pressed down so much that it would have meant that the valve itself would have been very difficult to move. Lubrication would have been quite difficult. And Peter has also determined that with the sort of design work that George Phipps had put in, that there was actually the risk of throttling of the exhaust route as well. Now I'm going to bring you over to the left-hand side. This is drawings, which is absolutely splendid drawings, which Peter has produced for the report, showing, first of all, this is how it was intended to appear. So this is a more detailed version of what George Phipps was sketching out on the right-hand side. So you can see that the steam passages are very short from that original arrangement, because it was so much easier to cast the short steam passage than the long. Now, for the reasons I've just outlined, in fact, the design was altered at the very last moment. Now we know this because the engineer who visited from the Navy Board, whose name now escapes me, but anyway, a good child, that's right. He saw during his visit this long slide valve. He actually saw it, but it wasn't used. So in other words, in the very final week almost of the manufacture of Invicta, it was decided that these problems were too difficult to solve in a short time, with the Canterbury and Whitstable desperate for Invicta to be delivered. And it was decided that they would put in an intermediate casting, a separate casting, which included that long steam passage that they were trying to avoid. So they gave up in the end and decided that a separate casting would be required. Now that decision was made at the last minute, so it allowed them to have a short valve chest. The steam passages were in that intermediate casting. Now, there was one problem with this, and that is that the original casting for the cylinder, they didn't want to have to cast another cylinder, the valve face was raised up above this level by about 3/8 of an inch. Now, John Glitherow and I saw on Rocket the way that they did this. They had this 3/8 inch above the rim, and by placing this casting on the top, you have in fact therefore got a huge gap, a 1/2 inch gap, and that was why they needed this very thick seal putting on. And so this is extraordinary. I mean, this is development engineering at the very the coalface, as it were. This is what they were doing on a particular day in March of 1830, after the visit of the Navy Board engineer. I think this is so exciting. You can actually hear the debate on the shop floor between George Phipps, who sketched out the original drawing, the foundry foreman, and also, of course, not forgetting William Hutchinson, the works manager, shall we call him, who had to make the final decision. And his decision was, let's go for that intermediate casting that we've just been pointing out. So we're learning an awful lot about the way that the Stephenson Company itself designed and developed and made progress. And the third drawing over here, this is a later locomotive that was made by the Stephenson Company for the Liverpool and Manchester Railway. This is the Northumbria. And you can see here on the drawing that was after being manufactured, you can see the long valve chest has been added to the cylinder. So they overcame the design problems that they experienced on Invicta and actually went ahead with this design, succeeding where they had yet to succeed with Invicta. Right, the next one, another of Peter's splendid drawings, which have helped to the report so much. We have the side view and the end view of the valve gear. The valve gear, well, I won't go through all the different motion, but it was actually driven by eccentrics on the rear driving axle. Again, very similar indeed to that which John Glitherow and I saw on Rocket. You had two dogs fixed to the axle and with the eccentric cluster moving axially between the two by a yoke. In fact, we can see it much better in the photographs. This is Invicta as it is now. Here is the first of the dog, the forward dog, and the other one is engaged, which is the reverse dog. This whole eccentric cluster moved axially that distance to disengage from one and re-engage from the other. Here is the dog itself, and here is the slot into which it engaged. In between is the yoke, which moved that from side to side. This is the photograph of Rocket, which John and I took back in 1999 when we undertook the Rocket project. Here is the dog and the slot. Here is the other dog. The whole assembly moved from side to side by the movement of this yoke. And the yoke is attached to a cross shaft, and that is linked to a foot pedal. In Invicta's case, the foot pedal is on the left side of the locomotive, the driver standing on the left side running board and depressing the pedal as and when he required. Right, let's move on to the next component. This is a photograph of the model that we saw earlier. This is Fletcher, his model that we saw earlier. It shows the leading end of the boiler, in the crown of which is the regulator valve that is protruding up. From there, it is conical in shape, and the steam is directed as required into the two steam pipes on either side going towards the valve chest, and is opened by the regulator handle here rotating the valve inside. That's how it's displayed on the model, and that's how it would have been built when the Stephenson Company built the locomotive back in 1830. Again, coming back to the photographs that John and I were able to obtain from Rocket, here is Rocket's regulator regulator itself, housing, whereas in Invicta the steam is exiting vertically. In Rocket it's going horizontally through the back plate, but the principle is exactly the same. And here is a picture of the actual regulator valve itself, conical to fit into the housing, and the steam passage is determined by the openings in regard to the actual steam pipe locations. So that was very interesting to understand that, in fact, this system had been used on Invicta. No surprises, of course, because it was like that on Rocket. Of course, they would do very much the same thing. The next component is the feed water pump. The feed water pump on the model is shown on the right side of the firebox. You've got the water coming from the tender. You've got the pump itself with the pump rod going forward to the crosshead on the right-hand side. It's crosshead operated. And here is the clack valve, which allows the water into the firebox. Not the best place to put it, incidentally, but the rest of the locomotive was a bit crowded. And so that arrangement was done by the workmen doing the best they could and in the factory in the time available. Now, when Cadbury came to rebuild the engine, he left the feed water pump in exactly the self-same position, except that, of course, it was the clack valve was fed into the fourth boiler ring, and the pump itself here, you can just see the pump rod going forward to the originally to the crosshead on the right-hand side. Right, now we come to the first photographic evidence. This is believed to be the earliest photograph taken of Invicta. It was taken in 1875, just before it went to the Jubilee exhibition in Darlington for the 50th anniversary of the Stockton and Darlington Railway. But what is so useful is that this is how it was in Ashford Works in 1875, but for the addition, which had just been put on, of the chimney, and the chimney sitting on a box. That's all it is. It's just a stand on which to put the chimney. ever since, it's always been thought of as being a rather odd shaped smoke box, but it's not that at all. It's just a stand for the chimney. The wheels we'll come back to because they're important. Now, the valve gear above the frame is missing. The driving motion is missing. The regulator valve is missing, and the steam pipes are missing, and indeed the exhaust pipes have got long gone. And so this rather sort of pared down locomotive, as it was then, has actually obtained a rather odd dome-like component. So what's going on here? Well, Peter and I realized that what had happened to Invicta when the South Eastern Railway had taken over the Canterbury and Whitstable is that they saw Invicta as an asset to be used to good effect. It was not seen as a sentimental artifact. And so what they did, they took it to Canterbury, they removed the leading wheel set, and they placed the boiler onto a plinth or a stand of some sort. And they needed the boiler to provide the steam for either a pump or for equipment inside the workshop. So they put on, at that time, in 1847, 48, thereabouts, they put on this steam riser, for want of a better term. Now, the next photograph, I can show you this as it is now. Here is the steam riser. It's a wrought iron one with a button strap fixture. You can see the rivets there. And this is taken on the inside by leaning down through the inspection hatch and placing the camera underneath and taking a photograph that way. And you can see that at the top there is just a simple opening from which the steam could be directed through a regulator valve through to the workshop or to the pump house or whatever it was used for. And that's what happened to it, which is not surprising, but it's never been understood before this investigation. So the next one I've got here, I'm going to introduce now the third of the four personalities who had such an effect on Invicta, James Janssen Cudworth. Now, Cudworth was the locomotive superintendent of the South Eastern Railway, who was based at Ashford. He also had been an apprentice at the Robert Stephenson and Company factory. He would have known, on the old boys network, he would have known Edward Fletcher, who by then, of course, was the locomotive superintendent of the North Eastern Railway. And he was who had duties in respect of that Jubilee celebration in 1875. Now, we don't have the evidence, we don't have correspondence between them, but you can imagine that Fletcher saying to Cudworth, look, I remember Invicta, that was my first locomotive and I came to Kent to assemble it and so on. Do you still have it at Ashford? And could it be made available to come up to Darlington for the Jubilee? So Cudworth was left with the problem of how to reassemble a locomotive that had lost most of its components. So the chimney and the stand I've explained, but now we have come to this knotty little problem of the wheels. Now they are prominent on Invicta and everyone associates Invicta with odd wheels, but where on earth did they come from? Because the original wheels that the Stephensons had put on were wooden in exactly the same way that Rocket's wheels were wooden. They were all wooden all the way through 1830, and the iron wheels did not come through until rather later. So where did these wheels come from? This is a petal form wrought iron wheel on the leading axle, and on the rear axle we've got a cast iron, hollow cast iron wheels on the rear axle. So where did they come from? Where did Cudworth find these wheels from? He had a real problem, because the workshops in Ashford, they were used to dealing with locomotives whose driving wheels were 4'6", 5 feet or 5'6", not 4 foot. And industrial locomotives usually had wheel diameters of, say, 3 foot, 3 foot 3, 3 foot 6, but 4 foot falls between those two categories. So there were actually very few locomotives that had wheels of that sort of dimension. So it is, therefore, he would have had to have found them from a second-hand scrap dealer. Wow, locomotive dealer, should we call it? Well, the most famous of all of the second-hand dealers was Isaac Watt Bolton of Ashton-under-Lyme near Manchester, the story of the Chronicles of Bolton Sidings. We don't know whether the wheels were obtained here or at another similar dealer that is just not written down. There is no evidence whatsoever. So I've looked further afield as far as I possibly can to try and find a locomotive with wheels that were similar. Now here we see the Victoria of 1837. I found this photograph in the Stevenson Locomotive Society journal in 1952. And it was apparent that the wheels on this, the whole loco was made by Benjamin Hick and Son of the Soho Works in Bolton. And you will see here that the wheels are cast iron. We know this from the records of the company have actually survived, not too detailed, but they have survived. And we are told that one of the types of components that the company made was to have hollow cast iron spokes to their wheels. And this is the nearest example I could find to that rear wheel set that we saw on Invicta. It's not evidence, but it's just an indication of where it might have come from when Cudworth tracked it down. So the locomotive was got ready for, first of all, for Darlington in 1875, and here in the second occasion in 1881 in Newcastle for the George Stephenson centenary celebration. And it's photographed by Bleasdale in the lineup of locomotives that were on exhibition in the infirmary sidings just to the west of Newcastle Central Station. But the important thing here is that the locomotive hasn't changed from that last view that we saw of the locomotive taken in Ashford in 1875. There are no extra components being put on there. So that's actually all that survives of the original locomotive. So after, in between each one, obviously it was taken back to Ashford. After the George Stephenson centenary, it was taken back to Ashford, and I believe it was put on some sort of plinth or something similar, out of sentiment now, because the two exhibitions, that gave it the status of a sentimental artifact. Now, for the last of the four chaps who had such a big part to play in Invicta's story, Sir David Salomons. Now, Salomons was a director of the South Eastern Railway. He joined the board in the in the early 1890s. He was also an enthusiast for engineering history. Now, had he been born perhaps just a decade later, he could perhaps have been a founder member of the Stephenson Locomotive Society in 1909, or indeed a founder member of the Newcomen Society in 1920. Such was his interest that he manoeuvred himself onto the Locomotive and Marine Committee of the South Eastern Railway in 1894. That gave him the opportunity of going to Ashford Works to have a nose round, and there he saw Invicta and got very excited by it and said, we must do something with it. So in 1895, just the following year, this drawing has survived. It's in the collection down in Whitstable now, and it shows the locomotive exactly as we saw it in the photograph earlier. Now, I'm pretty sure that this is an apprentice drawing, and I believe that he encouraged the apprentices to take on the task of preparing Invicta for display. In fact, he even proposed that Invicta would be displayed up in London on Charing Cross Station on a plinth up there. That actually fell through, but no matter. But it needed to have the missing components replaced. How do you go about replacing something that's not there if you're not an historian. If the apprentices have been given this task completely, you can't blame them for getting things wrong. But getting things wrong, they did, because they saw the locomotive that was in front of them, including this, in inverted commas, dome. And they said, well, the steam goes up there, and therefore it must be the way in which the steam was directed towards the cylinders. So they put out here in this extraordinary arrangement the regulator stuck out in the middle of nowhere and feeding these two extraordinary steam pipes feeding down to the steam chest. It was, of course, nothing like that in the original form. So this is pure make-believe, but it was what the guys at Ashford came up with when they reformed the locomotive at that time in the late 1890s. The driving motion was replaced and is very much the condition of that would have been made by a major locomotive workshop in the late 1890s. All the practices are there, all the straps and the cotters and so on are all very much of the 1890 practice. So eventually they completed the locomotive, and here we see it on completion. It's actually, this particular photograph was taken a few years later, but I'll come back to that. But this is how it looked when finished. So we've got an awful lot of fiction. The valve motion is not right. The steam pipes and so on, they're not right. There's a lot of errors in this, but they did the best they could. The first exhibition opportunity that the railway then had was in 1900, and Invicta was moved to Paris in 1900 to be put on display at the Exposition Universelle that took place in in Paris at that time. It was successful, so we're told, because here we've been able to track down a diploma which was issued for the display of Invicta in Paris at that time. You'll notice that it's awarded not to the South Eastern Railway, it's actually awarded to Sir David Salmon's Bart. Right, this in fact is now in the collection of the David Salmon's Museum, which is located near Tunbridge Wells. I have suggested that in fact, they have suggested that it would be possible for the certificate to be loaned on long-term basis to the Whitstable Museum. I don't know, perhaps David Banbury can confirm whether or not this has been taken up. So after that, with such sort of fame, in inverted commas, a further opportunity came in 1906 for Invicta to be put on display in Milan at another international exhibition. In the end, it didn't happen, but Salmon's decided that after all that had been carried out, that the locomotive should be put on display for the public benefit. And so in 1906, the locomotive was donated by the South Eastern Railway to the city of Canterbury. And this was taken on the August the 8th of 1906. Here is the locomotive on its plinth with the unveiling yet to take place, just like a sort of tarpaulin over it. Here's the Lord Mayor of Canterbury, and either this chap or this chap, I think, is Sir David Salmon's. They all made their speeches and all went off and had a cold collation afterwards. And there Invicta stayed in the Dane John Gardens in Canterbury from 1906 all the way through until 1977, with one exception. In 1925, it was taken down from its plinth. It was taken to Darlington and put in the exhibition of early locomotives that took place in Darlington to celebrate the centenary of the Stockton and Darlington Railway. So Invicta has appeared in the 1875 Jubilee celebration and the 1925 centenary celebration. And it would be lovely to think that it might actually be on display at the 200th anniversary celebration to take place in 2025, but that's another subject. Right, now we come back to the restoration of Invicta, which took place in 1978-79. Peter and I were able to see how bad the boiler had deteriorated. Various attempts have been made to plate it over the years. Some plates were early, apparently while it was still in stationary service, others much later. An awful lot of glass reinforced plastic had been inserted in 1978-79 to try and reinforce the bottom of the boiler shell and also the flue tube. The locomotive was completed in time for the 150th anniversary of the opening of the Canterbury Whitstable Railway, and took part in a parade on the 5th of May in 1980. And I took my family there for the event and took this photograph. You can see that cladding has now been added to the boiler. The two impressions of the former communicating pipes are still there. They're very prominent, and in the background, of course, is the cathedral. And one of the last things to show you is that the museum in Whitstable has asked for some indication to explain to the visitors there which parts of the locomotive are original and which parts belong to a different era. So the yellow is original components from Newcastle. The red is all the work that Thomas Cadbury carried out in 1836. The green is the work carried out early on in Ashford before and after its use as a stationary boiler. The purple is the work that was carried out probably by the apprentices at the works, and the grey was the work that's been carried out most recently. The chimney was so badly corroded in 1978 that they had to make a completely new chimney and a new stand as well. So that's now shows the visitor exactly what the history is as they visit the museum. Right, now we come to the conclusion. We reported our findings to the Whitstable Museum. They have now republished that, and it's now made available to anybody who wants a copy. If Peter Banbury is with us during the question time, he might be able to explain how to obtain a copy. Peter and I found the study both challenging and in need of great detective work to work our way through to answer some of the extraordinary stories that we uncovered. But above all else, it was a very, very enjoyable and satisfying project. Thank you very much for your attention.
Michael, thank you for an absolutely riveting and wonderful talk. It was a real tour de force. Thank you very much. We've got loads of questions already in. I will start and relay those now. If people have got questions, please put them on chat. I'll relay them through and then we'll get into a discussion. Please don't do it that quickly. I can't get them to. The first two questions are almost identical. Fred Starr and John Freeman asked the same question, which was the gasket on the valve chest. What was it made of?
Yes, Peter, do you want to answer that one?
Yes, it's a sort of material that we've found on other very early locomotives, early Stephenson locomotives. And I did a little bit of research and found an American recipe, but I think it probably applies everywhere. And I think you get red lead, which is a red powder, and you get white lead, the white powder. You mix it up and then mix it with boiled turpentine. And it gives you, or at least as far as I can see, it gives a wonderful material because you can build it up to quite decent thicknesses. I think we saw it about an inch thick in one of the locomotives. It's steam tight and it's structurally strong. And and it does wonderful things. It means you don't have to machine bolted surfaces, which are bolted cast surfaces. You just put this gunge on and bolt it up, and it's all wonderful. It saves a lot of trouble, and I suspect that they invented it in the early, in the 18th century when they were dealing with stationary steam locomotives, and just carried on with it.
Okay, thank you for that, Peter. Fred Starr asks, was a steam blast used? A good vacuum would be needed as the pressure drop across 1-inch tubes is likely to have been quite high. Yeah,
again, Peter, do you want to take that one?
I'm certain that a blast was used. It was well known. In fact, Trevithick had come to the conclusion that the blast was worth having a long time before. The trick really is to get the right amount of blast. So the answer is yes, it would have been used. And just as a little thought, you remember Michael said that after the boiler had been changed to a single flue, the journalist said that it flung out red hot coke left and right through the chimney. And it's just possible that they might have left the original blast still in place rather than softening it, because of course the single flue would require a much more gentle blast.
Just to add to your comments on the gasket paste, a not dissimilar recipe. My father had a plumbing and heating business, and it was a not dissimilar recipe was being used by him into the 70s. If you got into a very difficult situation on an old boiler that needed, let's say, a farmer was not going to pay an awful lot to have it done, it was a way around a problem. So old things don't die. Yeah. Simon Bass has added more of a comment. The role of Sir David Solomons is interesting. I believe the South Eastern Railway offered a Cudworth Mail Express engine to Ashford Borough Council in the late 1890s, but they rejected the offer. I suspect that Solomons was behind the offer.
Could have been, yes, could very well have been.
Richard Gibbons added a comment. I've loved every minute of your talk tonight, Michael. Thank you very much. Jonathan Ailin's come in. How was the lubrication arranged?
How was the lubrication? Well, there was nothing during the course of our project that would give us any evidence to answer that question. But what we do know from the rocket study that John and I did, that they used rape oil quite a lot, but various combinations of rape oil and whale oil, but they would have to be hand applied. Obviously, there was no automatic lubrication other than just the driver oiling round before each journey.
Chris Allen's coming with the question: what is happening to the Stephenson beam engine at Whitstable, equally important as Invicta?
Arguably, it's even more important than Invicta. That poor stationary engine from closed wood has been put aside for so many years. It has never been considered to be important enough to do anything with. Well, thankfully, it is now residing outside the museum in Whitstable. And the friends of the Whitstable Museum have great aspiration to reassemble that engine. There's an awful lot of components which have survived, but they need to understand exactly how to go about it, because it does need a pit, of course, for the flywheel to function. It's going to be expensive, and I look forward, if Peter's with us this evening, I don't know if he is, he might be able to bring us up to date with how they're progressing.
Peter, if you can bring us up to date, put your hand up. There's one or two of you got your hands up. I'll get to you in a minute. We've got loads of questions. We've got 14 more questions and people have got their hands up. Please bear with me. I'll get to everybody when I have chance. Ted Buckley is really a follow-up to the issue about the Whitstable engine. He's asking, is there any news on the winding engine part store at Whitstable? But you've answered that one. Sorry, I'm having to go through the Tom Nichols. Do any British locomotives have pedal wheel forms? I only recognise them in the Saxonia replica in Germany.
Yes, that's a very interesting one. Now, I've spent hours and hours and hours trying to solve this one. I recognise that Saxonia has got pedal wheels, but they're not of the same kind at all. There is no, in fact, when the original Comet locomotive, which was British built, was sent to Germany, it was sent not with pedal wheels. That pedal wheel was a particularly German feature on Saxonia. So there's no workshop pattern there at all. So I have not been able to find any other manufacturer who made wheels in that form. I haven't put this in the report, and I'm just speculating off the top of my head, but I do wonder if such was the problem that Cudworth had to try and make the locomotive available for the display in Darlington in 1875. Did he perhaps make a pair of wheels in that form? I don't know why he would have made them in pedal form. I have no idea, but I just cannot believe that the wheels came second. I don't know. It's just a complete mystery. If anybody has got any other information that they could make available to try and track down who might, which manufacturer might have made pedal wheels, I'd be very interested indeed to hear it.
Yeah, if people have got information that they want to pass on to Michael, please initially send them through to the events@newcomen.com email address. I'll pass them on to Michael if you haven't got his address, and I'm sure that Michael will get back to you. Richard Udin asks, firstly, have you any idea what the original spoke exhaust system looked like? Obviously, there had to be a way to remove ash, and was there? Well, we've answered the question about blast pipe, so it's really about the exhaust system and removal of ash.
Yeah, the exhaust system, I didn't have time. I couldn't go through every single component this evening, but that was one I actually missed out. But yes, the model illustrates quite well the exhaust route, should we say, and the manifold and entrance to the chimney at the rear of the chimney, with the blast pipe obviously curled up on the inside. So that route was known. The present exhaust system as displayed is a bit speculative. It's not far off the truth, but the route is similar, but it's a bit speculative.
Anthony, I'm going to come to you next after I've taken this question. Colin Megson asks, what thread forms were in use, and how and where were the threaded fasteners made?
Right. Again, nothing in this project allowed us time to investigate that. But John Glitherow and I investigated threads of the rocket when we carried out that study all those years ago. So, of course, at that time, the threads were made by the company themselves. And so they were particular to the company. Obviously, standard threads had quite a few years before they were introduced.
Okay. Anthony, if you need to unmute yourself so you can ask the question. Anthony Cox, that is, and then I'll come to John Clitheroe, who's put his hand up as well.
Good.
Anthony, can you come in? Okay, John, do you want to come in?
It's Anthony Cox here. I'm sorry, I didn't actually ask a question. You must be.
You put your hand up. That was all.
I must have touched something. Sorry about that.
Okay, sorry, don't worry about it, Anthony. No problems at all. Okay. Richard Udin's come in again. Secondly, are the fish-bellied rails under today's exhibition original ones?
Yes. They have been. No, what's the story? We need John Liffin to answer this one, because John has been advising the museum about the rails. I believe they are originals that have been accompanying the locomotive during its display career. I believe so.
Okay, Colin Megson's come again. What wall thickness was the copper tubes? Were they seamless and hot or cold drawn? Where were they made?
Right, they would not have been seamless. They would have been seamed and brazed in the Stephenson. Well, no, they were subcontracted by the Stephenson company to one of the other companies in Newcastle. Now, if I'd known this question was being asked, I could have actually referred to the investigations that I've carried out about the Stephenson company's early history. and we do know the name of the company who actually made those available, but then they are seamed. As to the thickness, they were where are we? 1 3/8 on the inside, 1 5/8 on the outside. So that's
quarter inch.
Yeah.
Did Colin mentioned, did the pistons have metal piston rings or such, and were bronzes used for the bearings?
Peter, do you want to take this one?
I'd be happy to, but would you repeat the question?
Okay, the question was, did the pistons have metal piston rings, and were any bronzes used in the bearings? And we have a second question on the bearings as well from Richard Udin, which is the photo of the axle bearings, the brasses seems to have been inverted. I presume it's probably that the top bearing brass was missing.
As far as the axle boxes are concerned, as I remember, it was all cast iron. But beneath the axle box, it was the habit or tradition to put in a piece of metal, well, partly as part of the whole horn assembly to stiffen it up, but also shape it so that it looks as though it will fit around the axle, just to keep the dirt out. Obviously, the axle itself will be going up and down with the springs, and these pieces below are fixed, so there's always a gap between them. But as far as I remember, it's cast iron. With regard to the pistons, Michael, I think, probably knows more than me, but I seem to remember that they were using, Stephensons were using brass piston rings at the time, which were forced out with springs in an adjustable way, so that you could take up any wear.
Yeah, that's correct. Yeah.
Okay. Did the pistons? Okay, there's a sort of supplementary to that one from Christopher Bell. Did the pistons use piston rings, or were they just near interference fit? But you've answered that one. Also, do you have any idea what the original working pressure would have been?
Right. Well, it's always been said that it was £50 per square inch, but I think we have reason to believe that it was probably something less than that. But it was nominally 50 psi.
Okay. And Tom James is asking, what suspension does the Loco have? And is it original or from a later restoration?
Right, the springs we can say about, because the leading spring sets were removed in 1847, 48 or whatever, and were replaced in the 1890s when Ashford replicated so many of those components. The spring sets that are on there now are those original ones, and we know that on the third plate down it is stamped Krupp and so on, 1893. Now that suggests, of course, that Krupp's supplied spring steel to the Ashford works at that time, and they used a spring set correspondingly for the locomotive. The only thing that happened in 1978 at York for the restoration is that the can't think of the word, the
Buckle.
The buckle, thank you, Peter. The buckle was replaced because the original one had deteriorated so much in the open air, and so they replaced the buckle, but the actual spring steel was reinserted.
Tom James has come in with a comment, just a historical thought, re Cudworth. His relationship with the South East Railway Board was strained in the period 74-76, so it would be interesting to know how much attention he was able to give to the rebuild and the trip to the exhibition. More of the thing. John Clayson's come in. It's a long one, so I'm going to have to read it in part. The comparison between Invicta and Rocket is very interesting. Going back to their individual specifications, Invicta appears to have been designed for a specific task on a new railway. Rocket was designed to win a competition in which such things as its power weight ratio and speed capability were relatively level route were critical, for which reason it has only one driving axle. Do we know how much learning from Rocket's performance during and after Rainhill was applied to Invicta?
Right, now I can answer that one. Again, time prevented me including it in the talk earlier. When the Canterbury Whitstable board asked for a locomotive capable of hauling a decent train load up the Church Street incline, Robert Stevenson took this on to investigate in what form to specify the layout of Invicta. He waited until the first of the post-rocket locomotives had been delivered to the Liverpool and Manchester Railway and carried out tests with it on the incline at Rain Hill to establish rather better what sort of performance it could usefully have and whether it was feasible for a locomotive to haul a train up that Church Street incline. As a result of that trial, Robert Stevenson came up with this arrangement. Now we know about their background, by the way, because we have a letter written by Robert Stevenson to the board of the Canterbury and Whitstable Railway, telling us that that's what he was doing. So this is Robert Stevenson's laying out, and of course George Phipps took on the basic layout which Stevenson had laid down and turned it into a reasonable design feature.
We have 3 more questions. Oh, we have 4. Are you confident of the driver's position as Invicta has been rebuilt? It seems to me that this is from Tom Nichols. It seems from me that the painting from the opening days puts a man behind the locomotive standing on the bank track side in exactly the same position as if he was standing on the boiler planks of the restored locomotive. Would the driver really have stood on the boiler? Is it possible this can stem from the painting? So in other words, what was the layout for the driver's position?
Right. As it is shown there, the driver was standing on the left side running board. We know this because the foot pedal for the change of direction is in his foot's reach where he's standing there, but also the regulator handle is also in that mid-boiler position. So that driver's, in inverted commas, standing there, he's standing in the right position. The chap who might have been standing behind the boiler would have been the fireman. Okay. And incidentally, the lads at Whitstable told Peter and myself that model of the driver, the left hand, his left hand is just, it looks as though it's gripping something. And so what the friends of the museum have done from time to time is to insert a mobile phone into that driver's hand. And then when the children come in, they all say, now, what's wrong with the driver? What's he doing wrong? And none of the children know.
Yeah. Colin Begson's come back on. Were safety relief valves a consideration in these early designs?
There was a safety valve on the boiler top, yes. There is still one there now, but of course it's been moved from the 3rd boiler ring to the 4th boiler ring, which would have been undertaken by Cadbury. The one that's on the actual valve that's on there now was replaced in the 1890s, I suppose.
Fred Starr's come back again. Well, when they decided to go for a single large flue, it would be back to locomotive 1 practice, which was short of steam. But the runs that Invicta were making were so short, they would know this wouldn't matter. Okay, so it's more of an observation.
That's absolutely right. Yeah.
John Glitherow's come in. We measured some thread profiles. We measured some thread profiles on Rocket using dental putty. A 3/4 inch bolt was 10 threads per inch like Whitworth, but 63-degree thread angle instead of 55. Again, much more of an observation. John Clayson's come in. How did the Councilman and Whitfield Railway prevent runaways with locomotives haulage and primitive brakes on the Church Street incline?
I don't know is the short answer. We saw no evidence of brakes at all, of course. I think there may have been one on the tender, but no, I don't know.
I think at this, I think we'll have to make this the final question. Colin Begson asked, was coal grade and cobble size a consideration?
it was burning coke rather than coal.
Okay.
I think is the answer. The original firebox arrangement, it needed coke in much the same way that the locos on the Liverpool and Manchester used coke. Apparently, from that press report, it would seem that when they converted the loco to the single flue, they carried on using coke, which was quite an interesting point.
We have the end of the questions. All I think is left to me to do now is to thank you, Michael, for an absolute tour de force. Thank you, Peter, as well, for supporting Michael on this. It's an absolute brilliant piece of research. For people, two things really as comments. I will email everyone who has booked details of where you can get Michael's report from. So basically you can follow that one up. If anyone would like to join us for Michael's talk on Killing with Billy in November, please email me on the events@newcomen.com email address, and basically I will make sure you get sent details. And I've probably got to really do this plug now. If anyone wants to join Newcomen and basically take part in our lectures and get our things, send me your details and we will put you on our mailing list and we will make sure you get details for talk. Michael, Peter, thank you very much for an absolutely brilliant talk. You have lots and lots of accolades coming in now. I will save the chat and I will send it to you so you can be embarrassed in private. Thank you all.
Everyone.
Thank you, everyone. You had a peak audience of 178.
Right, well, that's about the average, 178 out of 222.
So
that's pretty good.
Is that an all-comers record for you?
Well, I think the previous one was that lecture I gave in Edinburgh that Peter was at on the Eric Lomax Memorial Lecture. That was about 160. So we've beat that.
We beat that one. But no, the only question I've got, which was one I was going to pick up on, is any